Hey class, Mrs. Anderson here. This video is going to go with 1.5 piecewise functions. By the end of this lesson, we should be able to evaluate piecewise functions and graph piecewise functions. So a couple of vocabulary terms for you first. What is a piecewise function? It's a function represented by a combination of equations, each corresponding to part of the domain. And then we also have what's called a step function, and that's a function that increases or decreases from one constant to another. One thing I want to point out is since they are both functions, they both must pass the vertical line test. And that'll be a good way for us to just double check that we've graphed these functions correctly as we go. So since they're functions, they do need to pass that vertical line test. So let's start by just evaluating some piecewise functions. So here is a function that's represented by a combination of equations. We have f of x equals 3x plus 2, and we have f of x equals x minus 1. And then each equation corresponds to a different part of the domain. 3x plus 2 corresponds to when x is less than or equal to 3, and x minus 1 corresponds to if x is greater than 3. So two equations corresponding to different parts of the domain. To evaluate a piecewise function, you need to remember that these are in function notation, so these are f of x. So the first one is asking me when x is equal to 0, what does the function equal? So first I look up here and I say, well, 0 is less than or equal to 3. So that's going to go in the top one since 0 is less than or equal to 3. So then I'm going to use the equation 3x plus 2, and I'm going to plug in 0 for x. So it'll be 3 times 0 plus 2. And 3 times 0 is 0, plus 2 is 2. So f of 0 equals 2. It's kind of like saying when you plug in 0, you get out 2. That's the ordered pair. 0 input, x output is 2. For 3, 3 is, we go back up to our function, is also less than or equal to 3. So we use the equation that I highlighted in yellow here. So again, you're going to plug in 3 for x. 3 times 3 is 9, plus 2 is 11. So f of 3 equals 11. You plug in 3, you get out 11. And for 6, since 6 is greater than 3, you're going to use the x minus 1 equation. So 6 minus 1 equals 5. F of 6 equals 5. So that's how to evaluate a piecewise function. You ask yourself what part of the domain corresponds to that x value, and then choose the correct equation to plug it into. Graphing the piecewise function. There's more than one way to go about this, but this is how I like to do it. I like to graph this. First, I have 3x minus 4 and negative x plus 1. So essentially, I have two linear functions. So I'm going to have two lines. One piece, two pieces, they're going to be each be lines. And these lines split at x equals 2 because that's where my domain is. I have 3x minus 4 if x is greater than 2, and I have negative x plus 1 if x is less than or equal to 2. So the graph split. So I graph this in two different parts. I first graph y equals 3x minus 4 when x is greater than 2. And then I will graph y equals negative x plus 1 when x is less than or equal to 2. And the way that I do this is I just make a table. And I choose x and y points. So on my left side, I have to pick points where x is greater than 2, but I always start with my domain number 2, and then I pick x's that are greater than that, like 2, 3, 4, and 5. And then I plug those x's into the equation for x and solve for y. So the first one I would get 3 times 2 is 6, minus 4 is 2. And I would continue doing that. So 3 times 3 is 9, minus 4 is 5. 3 times 4 is 12, minus 4 is 8. 3 times 5 is 15, minus 4 is 11. Then I'm going to do the same thing over here. Since my y, or my x, splits at 2, that's the first value in my table again. But this time I need to choose x's that are less than or equal to 2. So I choose x's less than 2. So start at 2, and then I go 1, 0, and maybe negative 1. And then I'm going to plug them into the second equation, negative x plus 1. And just so we're clear here, negative x plus 1 means that it's like negative 1 times x plus 1. So this would be, for plugging in 2, you'd have negative 2 plus 1, you get negative 1 out. Negative 1 plus 1 is 0. Negative 0 plus 1 is just 0 plus 1 is 1. When you do negative 1, that becomes positive 1 plus 1 is 2. So I have my points here. And then I need to graph these. So then the only other thing we really need to remember is that if we were to graph just on a simple number line where we had 1, 2, 3, and we graphed the inequality x is greater than 2, you would put an open circle at 2, and then you would draw it to the right because it would not include 2 because 2 is not greater than 2, it's equal to. So it's an open circle and it goes to the right. If you were to graph x is less than or equal to 2, or I guess we'll keep the sign the same way, greater than or equal to 2, you would graph that as 1, 2, 3 the same way, but it would be a closed circle at 2 and going to the right. So it kind of makes this the same idea when you're graphing these piecewise functions for your very first point. Since this one is just on the left here is just greater than 2, this very first point at 2, 2 will be an open circle because it's not equal to 2 there. And then since the one on the right is less than or equal to 2, it'll be a closed circle at the first point there. Oops, one too many circle. Oops, sorry. Okay, so 2, 2. I'm going to graph the one on the left here. So I'm going to graph this line here in green. So 2, 2, I have an open circle right there. And then I have 3, 5. So over 3, then up 5. And then 1, 2, 3, 4, 8. And 5, 11 is off my graph. So I start at the first point and I draw an arrow going through my other points. Then I'll graph this one on the right in orange. So I'm going to start with my first point is 2, negative 1, but this time it's a closed circle. So I have the point 2, negative 1, closed circle there. Then 1, 0, then 0, 1, and then negative 1, 2. I started at 2, negative 1, so then I start there and go this direction. Remember that this is a function, so it must pass the vertical line test, which it does. This point right here at 2, this is where the graph is split. It passes the vertical line test because this is an open circle and this one is a closed circle. So really there's only one defined point there. So it is in fact a function, and that's how you graph a piecewise function. So I have a couple more examples. For the sake of this video, I am going to skip example 3 because it's very similar to example 2. But please see my notes if you want that one filled in on Schoology. And I'm going to go down to, well, I guess it'd be example 4 here. I'm going to graph this piecewise function. So here we have f of x equals 2 if x is less than 1. And then we have the second half of the function is f of x equals 1/3 x plus 5 if x is greater than or equal to 1. So here we have our graph splits at x equals 1 essentially. So we have two equations. We have y equals 2 when x is less than 1. And we have y equals negative 1/3 x plus 5 when x is greater than or equal to 1. So in my table, I'm going to draw a table for both ones. Since my graph splits at x equals 1, that's going to be the first x that I choose in both tables. I have to start with that where the graph splits at 1. On the left side, x is less than 1, so I'm going to choose 1 and then values that are less than 1, like 0, -1, -2. And then on the right, x is greater than or equal to 1, so I'm going to choose values like 1 and maybe 2, 3, and I'll come back to that in a second. So over here on the left side, I'm going to plug in 1. Well, there is no x in my equation. Y equals 2, which means that y equals 2, y equals 2, y equals 2, y equals 2. Remember, y equals 2 is just that horizontal line, so everywhere y equals 2. On the right side, if I plug in 1, I'm going to get negative 1/3 times 1 plus 5. That's going to be 4 2/3 essentially, or 4.6 repeating. So I got 4.6 repeating. Plug in 2, negative 1/3 times 2 plus 5. That's going to be, remember when you take a fraction times a whole number, you can put the whole number over 1. And then it's going to be top times top over bottom times bottom, or numerator times numerator over denominator times denominator. So it's negative 2/3 plus 5. Well, that's 5 minus 2/3, so that'd be 4 1/3 left. So you'd have 4.3 repeating. And then negative 1/3 times 3 plus 5. So put the 3 over 1. Then you'd have negative 3 over 3 plus 5. Well, that's 5 plus negative 1, which would just be 4. So since you end up dividing by 3, if you pick numbers that are divisible by 3, like if I pick my next one to be 6, I'm going to avoid that decimal that I'm running into. So negative 1/3 times 6 plus 5. 6 over 1, that'd be negative 6 over 3 plus 5. That's negative 2 plus 5, so you'd end up with 3. So if you have a fraction, remember that this negative 1/3 is like times 1 divided by 3. So if you pick numbers that are divisible by 3, then you can avoid decimals. If you have a calculator, that can help you out to plug those in too. Okay, so going back to graphing, we'll graph this left one here in green first. And since it's x is less than 1 here, my very first circle will be open at 1, 2. Because it's not equal to 1 there. So I go to the right one and then up 2. And then it's less than 1, so 0, 2, negative 1, 2. So I'm going less than 1. It's just going to be a horizontal line that way. So from there all the way over. And then here on the right, I'll graph that one in this pink color. I got 1, 4.6, since it's equal to 1 here, this circle here will be closed. So at 1, and then I'm going to have to just do my best to estimate 4.6, but it's going to be a closed circle. And then I'm just going to go to 3, 4 for my next point, and then I'm going to go to 6, 3. And then I start at that 1 and 4.6, and then I'm going this way. So again, remember that it has to pass the vertical line test, which it does. I have one open circle and one closed circle that line up, but since it's open and one closed, that is still a function. I'm messing up my words. Okay, last example here is a step function. So a step function it kind of ends up looking like stairs. These are constant values between the intervals of y. These are constant values of y between intervals of x. So remember, my x-axis is here and my y-axis is here. So I'm going from steps 1, 2, 3, 4. So I'm like going 1, 2, 3, 4 along the y-axis. But then I'm on the x-axis, I'm moving from left to right. So y moves you vertically and x moves you from left to right. Whenever you see the less than or greater than sign, you're going to have an open circle. And whenever you have a value at less than or equal to or greater than or equal to, you'll have a closed circle there. So you'll see, like, here's my first one. My first step, y equals 1 between -4 and -2. So I'm going to graph this very first one right here. So I have 1 between -4 and -2. It's closed at -4. And it is open at -2. And y equals 1. Remember, this is my y-axis, so y equals 1 is right there. And then x equals -4 and x equals -2 is right there. So I go between -4 and 2 and up to step 1. And then I'll do the next one here. We got 2, so I go to y equals 2 between -2. It's closed there. Whoops, I got to change back from my highlighter, back to my pen. Closed circle at -2, and that one goes to an open circle at 0 for x, and y is equal to 2. Then we got the next one. We are at from 0 to 2 on the x, we are equal to 3 on the y. And then the last one is equal to 4 from, so this is 2, this is 4. We got a closed circle at 2, open circle at 4, and y is equal to 4 there. So that's my step function. See how it kind of looks like stairs stepping up? So essentially, you know, my y equals 1 between -4 and 2, y equals 2 between -2 and 0, and so forth. Okay. Thanks for watching. Certainly come ask for questions. If you have them, let me know. Seek out some other resources if you need it. And have a good night.